Okay, section 1.6, other types of equations. One of the big issues when we finally get to a test over the chapter 1 material is we will have studied a lot of different types of equations. We'll have studied linear equations, rational equations, quadratic equations, polynomial equations, radical equations, rational exponent equations, and absolute value equations. That we'll have studied at least 7 different types of equations, and what you will have to do is when it comes to test time, they're all just going to be mixed up together. You have to be able to recognize each type of equation and then apply the correct steps. And so it's one of the things when we've been working through them that I have tried to, when we're talking about quadratics, like, oh, there's an x squared as the highest exponent, it's a quadratic, that you have to learn to recognize them and apply the appropriate steps. So our first type that we're going to talk about here is a polynomial equation. A polynomial equation is an equation that has only whole number exponents and no variables and radicals or denominators. So there's how you're going to recognize it. Only whole number exponents, no variables and radicals and denominators. And remember, whole numbers, 0, 1, 2, 3, 4, so on. So only whole number exponents, no variables and radical denominators. Our primary method of solution will be factoring. You will note that the steps are the same as solving a quadratic equation by factoring. They are the same because a quadratic equation is a special case of a polynomial equation. So you really already know these steps, just that the factoring is going to be a little bit different. So steps to solving a polynomial equation by factoring. If the equation contains a fraction, clear the fractions. That's going to be just our first step about any type of equations. If it contains a fraction, clear that fraction. 2, if necessary, rewrite so the equation is equal to 0. 3, factor. 4, split up. And again, it can only be split up if it was factored and equal to 0. If you split things up, when you're solving an equation and you split up things that are not equal to 0, you're just going to lose all the points. That step of splitting things up is only true when it's factored and equal to 0. Solve each resulting equation and then check. So let's solve this guy. So first of all, we're going to recognize that it's a polynomial. Polynomial equation. Only whole number exponents. No variables. In radicals or denominators. So my first step is to set it equal to 0. So we've got 2x cubed minus x squared equals 4x minus 2. It does not matter what side that 0 is on, so I'll just move everything to the left, which changes my signs those last 2 terms, and then I have it equal to 0. Okay, so again, factoring is supposed to be one of those skills that we hope you bring with us, but now we need to factor it. And because it's 4 terms, we're going to try to factor by grouping. So remember factoring by grouping. You group some terms together. Now, not that it will always be first 2 terms and the last 2 terms, but the way they have a tendency to write textbooks, that's the way it usually works, but it doesn't have to be. Now, once you've grouped your terms together, you then take out a common factor. So out of the first 2 terms, I can factor out an x squared, leaving behind a 2x minus 1. And now out of the next 2, I can factor out a 2, but I want to create an identical factor over here. Actually, what I want to create is a 2x minus 1. I want a positive 2x. And so what I'm going to factor out here, because this is negative 4x, I'm going to factor out a negative 2. And then because I'm factoring out a negative 2, that's going to change my signs to positive 2x minus 1. Remember, whenever you factor out an entire term, a 1 is left behind, because you really are doing a version of division here. 2 divided by 2 is 1, equals 0. And then because these are identical, I can now factor them out. And so I can factor out the 2x minus 1. And it really is a greatest common factor. So you move out that greatest common factor, and then you write what's left behind. And what's left behind on the first term is the x squared. And what's left behind on the second term is the minus 2 equals 0. And now it's factored equal to 0. So I can split it up. And so 2x minus 1 equals 0. X squared minus 2 equals 0. And then you just decide what to do from there. And so I'm going to get 2x equals 1/2, or 2x equals 1, x equal 1/2. This I can do very nicely by the square root method. So I'll move that 2 to the other side. Then I can take the square root of both sides, including that plus or minus, and I get x equals plus or minus the square root of 2. And remember, forgetting the plus or minus is not a minor mistake. It's a major mistake. Anytime I'm solving an equation and I have to take the even root of both sides, in this case a square root, whenever you're solving an equation and you take the square root of both sides, you include a plus or minus. And so here I get 3 answers. Because my exponent, my highest exponent, that's called the degree, and we'll talk about that more later. Because it was degree 3, I can have up to that many answers. You don't have to have that many answers, but that's the maximum. And I get 3 answers. And just like all of these, I can check this by graphing. As long as you get real number answers, things without i's, you can check by graphing, which we have on the next page. You take it all to one side, type in the equation, and then graph it. Square root of 2 is roughly 1.1414, and it does look like my x-intercepts would be okay there. That one right there, let's zoom in a little bit. That looks like that would be close enough to negative 1.414 to make me happy. That looks like that is 1/2, and that looks like it's close enough to 1.14 to make me happy, that your x-intercept should match up with your answers. And if I'm quickly checking, that graph gives me enough confidence. Okay, let's zoom back out. And let's look at the next problem. Again, it's a polynomial equation. So my first step is to set it equal to 0. So 7x to the 4th minus 56x squared equals 0. And then we factor. And so initially this factors that I have a greatest common factor of 7x squared. That I have an x to the 4th, x to the squared, x squared. You can take out the smallest, so x squared. 7 is certainly divisible by 7, and 56 divided by 7 is 8. So I take out a 7x squared, which is going to leave me x squared minus 8 left behind. It is now factored and equal to 0. So I can split it up. And that step of splitting up, only legal when it's equal to 0. So I'm going to get 7x squared equals 0. X squared minus 8 equals 0. Solving this, I'd get the x squared along. So I get x squared equals 0. And same thing over here, getting the x squared alone over there. I take the square root of both sides, and so I get x equals plus or minus, and 8 is 4 times 2, so plus or minus 2 square root of 2. And essentially doing the same thing over here. And if you've listened to me over and over and over again, you're going to put the plus or minus there, but in this case, the plus or minus doesn't make any sense because 0 is neither plus nor minus. 0 is just 0. So I don't have a plus or minus 0, it's just 0. So really, I shouldn't have put the plus or minus there. But I would much rather have you put the plus or minus on the 0 and remember to use it every single time you need it than to remember, oh, I don't need it here, and forget it someplace else. When in doubt, take the square root of both sides, plus or minus. And so in this case, I get 3 answers. Yes, there was a potential of 4 answers, but here I just get 3 distinct answers. And then you could check this the exact same way we've checked the others. So that's polynomial equations. Moving on, radical equations. We are actually just going to be doing square roots, but the steps here, same for all, same for cube roots, fourth roots. Steps to solving radical equations. 1, if the equation contains fraction, clear the fractions. That's just a common first step. Get rid of those fractions. 2, if necessary, rewrite isolating the radical. If there are 2 radicals, rewrite with 1 radical on each side. 3, raise both sides to the appropriate power. If it's a square root, square both sides. If it's a cube root, cube both sides. 4, simplify both sides, FOIL where necessary. 5, if a radical remains, go back to step 2. If all radicals are gone, proceed to step 6. 6, finish solving appropriately. And that's all you get there. Solve appropriately. Anything can happen at this point, so you just got to look at what you have and choose the right steps. 6, and then 7, check. Not optional. If you raise both sides to an even power, not optional if you raise both sides to an even power. When both sides of an equation are raised to an even power, extraneous solutions can occur. An extraneous solution is a number that creeps up perfectly logically, but really isn't a solution. Just like when we were doing restrictions, and you would hit upon a restricted number as an answer. That's an extraneous solution. In the case when I'm raising both sides to an even power, that opens up the door to extraneous solutions. Because, let's just take squaring. Squaring both sides. 3 squared is 9, negative 3, quantity squared is 9. That when I square both sides of an equation, it's as if the equation is forgetting about the difference between positive and negative numbers. And so that's what opens up the door to extraneous solutions when I raise both sides to an even power. It's as if the problem is forgetting about the difference between positive and negative numbers. So checking is not optional when you raise both sides to an even power. Okay, we're going to end this video and we'll come back and do the problem.